Hello everyone. Welcome to St. Andrews Institute of Technology and Management, Gurgaon, Delhi NCR. St. Andrews Institute of Technology and Management is the best engineering college and best college of management in Delhi NCR and around. It is one of the best college in northern India and ranks on top in entire India. It is the best education choice that you can make for yourself or anyone who's very close to you. So it is the finest college providing finest education in the industry. It provides 100% placement. The subject that shall be taken here is Principles of Software Engineering CSE 302F. This is a CSE 6 semester subject. This is in accordance with the syllabus of MDU University, Rohtak. The topic covered here would be software characteristics, software applications, software crisis, and I, Shalini from CSE department, shall be taking you forward. Software characteristics. What are the characteristics of software? Our previous lectures we discussed the kinds of softwares, the work they were being doing, what was the software. We just gained a basic understanding of it, right? So now it comes to like what will be the various characteristics of these software. These are six major components that are being divided by ISO. The first one is functionality, second is efficiency, third is reliability, fourth is usability, fifth is maintainability, sixth is portability. You may say, ma'am, there are acceptability, there are time adherence, but all this will be actually kind of we can subseed into some form or the other form. See, we study them now in detail one by one. First is functionality. Okay, now functionality. What is the general meaning or literal meaning of functional? See, it comes from the word functional. Functional means how it functions, how it operates, how it is carrying out its work, like what is it performance. So all this comes into functionality. Functionality refers to the degree of performance of the software against its intended purpose, right? So see, every software we discuss that it has a purpose. So you sit down, requirement analysis we were doing now, and unless and until it is being produced according to the standard, that only it is being deployed, right? So see, every of them has a intended purpose. So functionality would define as to how it is performing against its purpose, right? What are the various functions? Suitability, accuracy, interoperability, compliance, and security. See, first one is suitability. Now, what is suitability? As the name suggests, that how suitable your software that you made it is to the scenario or the work that is being for which it was developed. Since say if it is an attendance system or a kind of a software that are designed for biometric, so how suitable it is for it, right? If it is an ERP system, then you see how suitable it is to the work, right? So this is suitability. Accuracy. Now what is accuracy? How accurate it is, like to what precision it is correct, it is performing correctly, it is accuracy. Interoperability. See, if it is like anything which can be interoperable is a very very nice added advantage, I could say. Why? Because see, there are some languages that are platform independent, so that provide them very make them very convenient. So interoperability would really, if something can be run over various platforms, if any software can be run into kind of, it can be designed into a general way where it can be used by the different it can be run on to implement it into different hardware. So suppose if my is an attendance making app, and it is being operated into laptop, and similarly it is being operated into my mobile phones. So how good it is performing in both the cases, right? So that isn't, and these days usually website comes with this thing that how they will perform in the mobile mode and how they'll go into the laptop mode. So this is interoperability. Compliance, then it has to comply with the standards, or with any document that it was initially kind of signed. So it has to have compliance in it. Security. See, being secure is the very, I would say, advantageous. Why? Because security is very important. If many website, if I'm designing something and somebody is coming and putting it some documents or some kind of unrelevant stuff, I would say. See, like Wikipedia, with whom anyone can edit. So I would definitely not myself. If I like you, or say for example, you are the customer and you're designing something for yours. You're making a machine and you have a you it says NM to a machine, and you want your sensor to send something, and then say it's a video sensor, it's a camera sensor, and then somebody codes into it, hacks the security, and he actually stops the camera at a time when the robbers come. So it is no use, the entire purpose is defeated, right? So this is very important issue. Next we come to reliability. Okay, so what is reliability? It is a set of attributes that bear on capability of software to maintain its level of performance under the given conditions for a stated period of time. See, this has to, reliability means that when it is undergoing various kind of strains, or various loads, then how much it can bear, right? So this is reliability. How it is recoverable, it has three options in it, or there are three methods by which is being done. The first is recoverability. Then my software, if it damages, or it is being broken down and it's been disrupted, then it should need to be recoverable, right? Say with a particular code, I could need to recover my work. Fault tolerant, see, first of all, the recoverability will come after like a fall, when there will be some fault. So it is better to make it fault tolerant, so that it doesn't kind of breaks, or it doesn't kind of become a faulty thing, right? So it is meant to do its intended purpose, and you need to do that purpose, so it has to be fault tolerant, right? And then maturity comes like in the, it's a sense wherein the software has become matured, and it can see that there are these few errors which are supposed to be neglected, and these are the one that does not cause harm to my system, and these are the one that will cause harm to my system. So that is a maturity level, that this is to be uh, taken care of, and these are supposed can be dealt this can be dealt later on. So this is what I mean by this. Okay, see, efficiency. Efficiency is the ability of the software to use system resources in the most effective and efficient manner. The software should make effective use in terms of storage space and executive command as per desired timing requirement. Right? See, efficiency, up till now also we see that it is being, we say any system is being efficient if it is able to perform the desired task into minimum time, and with the help of minimum resources, by using minimum resources without doing any wastage of it. So efficiency, similarly for this thing also, it remains the same. It is both spatial and temporal, I would say, right? So in terms of resources also, and in terms of time also, right? So it has to be performed in minimum time by taking minimum amount of resources. See, why to waste the entire resources when it can be done into a very convenient, into a very efficient way? Okay. Next is usability. It refers to the extent to which the software can be used with ease. That amount of effort or time required to learn how to use the software. See, ultimately, the software purpose is to be able to be used for the customer who need not know the hardware, underlying hardware knowledge, need to have any information the how the hardware is working. The customer or the user doesn't want to have a knowledge of it. You see, if it's a washing machine, a smart washing machine, then the only purpose it needs, that I need to press the button, my clothes should get washed, and to press the button and it should be stopped, right? See, if it's a smart fridge or smart watch, anything, then he does not go into the underlying architecture of it. So from a user's point of view, we always have to make a software, we always look at the user's point of view as to what, how it is convenient to the, how it is being easily, can be easily used by the user, right? How it is, how it can be made easier for them, how it can be made comfortable with them, how their experience can be bettered, right? And this is classified into three, like understandability, how well he can understand the system; learnability, how easily he can learn it; and how easy it is for him to operate it, right? So all the thing, he should be very easily able to understand it, learn it, and also operate it. So this comes under usability. Next we come to maintainability. Maintainability refers to the ease with which the modifications can be made in a software system, right? So if I want to modify my software, it has to be done very very easily. I should not face any difficulty doing it, right? It is done to improve the performance or to correct errors, right? So it has to be very very easy. Maintainability is divided into again four parts. First is testability, stability, changeability, and operability. See, anything which has to be maintainable has to be easily testable, right? If I have very very kind of a difficult mechanism to test my bugs, then there's no point. I would take an entire kind of a month taking into time to testing it and finding the fault as to what exactly happened wrong with it. Then there's no point, right? So the testability has to be really good. Stability comes from the very tolerance kind of a mechanism wherein the software can become tolerant to small errors or environment change, or so it has to be stable, right? Changeability, for any small modification that occurs, say into the, for any change in the program that is coming, so it can have a range of it, right? So next is operability under different situations, under different scenarios, under different modes. So all this come under the maintainability, and this is all done to improve the performance and just to correct errors, for just for a better user experience. Okay, next is portability. See, portability is that it is easily portable, a set of attributes that bear on the ability of the software to be transferred from one environment to another environment, from one platform to another platform, without or with minimum changes. Like it can have no changes or very very least very very few changes, negligible, which can be negligible, right? So portability comes into three: adaptability, installability, and replaceability. Adaptable means my software is adaptable, right? Installability is it can be easily installed onto different platforms. Replaceability, that it can be easily replaced. All these features come, all the three features are part of probability. Then is software applications. Okay, see, what are the different applications of software? The most significant factors in determining which software engineering method and techniques are most important is the type of application that is being developed, right? So the first are the system software. This is a collection of programs that are written to service other programs, right? Say compiler, your device driver, your sound drivers, your graphic cards, your editors, your file management. These come into system software. Why? Because these are the programs that actually service other programs. So these are system programs. Next is the application software. These are basically used to solve a specific business need. It is needed to convert the business function in real time, right? So these are depending on your various need, whichever business application that you need for. Example, point of sales, like transaction processings, real time manufacturing control. All these are application softwares. Next we come to third, that is scientific or engineering software. See, these are based on astronomy, automotive stress analysis, molecular biology, volcanology, space shuttle orbital dynamics, automated manufacturing. So these engineering softwares, the CAD, CAM, these are all scientific softwares. These are all kind of come into this category. Okay. Next are embedded software. These are software control systems that control and manage hardware devices, right? So these are the ones that are actually controlling and managing the hardware devices. Example, your software in the mobile phones, the software in anti-lock braking in car, right? The software which can open your kind of emergency kind of emergency system into the car, that also comes in this category. The software in the microwave oven, that is controlling the cooking process. So all these are embedded software. Why? Because they're controlling and managing the hardware devices. Next we come to product line softwares. These are designed to provide a specific capability that is for use by many different customers. It can focus on unlimited or esoteric marketplace like inventory control products, or address mass market like spreadsheets, computer graphics, multimedia entertainment, games, database management, personal business financial applications. So all these are product line software. These are all kind of delivering their products. See, game is the biggest kind of an example of this product line software. Another web application. These are called the web apps. These are evolving into the sophisticated computer environment that not only provide standalone features, computing functions, and content to the end user, but also are integrated with corporate database and business applications, right? The last week comes to the artificial intelligence software. This include robotics, export system, your pattern recognition, image and voice, artificial neural network, the game playing, theorem proving. It is used to solve complex problems. So all the artificial intelligence software, like your Siri in your this thing. So this Siri is a assistant, right? So all this is a artificial intelligence software. Okay. So next we come to the software crisis. Software crisis is the term that is used in computer science for the difficulty of writing useful and efficient computer programs in the required time. Software crises were due to using same workforce, same method, same tools. Even though there are rapidly increasing software demand, the complexity is changing, it's become more complex, and the challenges are also changes, right? But you're stuck onto the same old tools, old techniques, and old method. With increase in the complexity of software, many software problems arise because existing models were insufficient. The same workforce, same methods, and same tool, after fast increasing in software demand, software complexity, and software challenges, then there arose some problems like the software budget problem, software efficiency problem, software quality problem, software managing and delivering problem, etc. So this condition was known as software crisis. See, right, in this diagram we can see there was this increased demand, increase in complexity, and increase in challenges. Whereas the workforce was same, the methods were same, and there were same tools. So all this led to the software crisis. Next, what are the causes of the software crisis? the cost of owning and maintaining software was as expensive as developing the software. So the maintenance was also running into any car. See, suppose if I use any car whose maintenance cost by far exceeds the buying cost, so that is of no use. It will create a crisis, like it will create a helpless kind of a situation. So this was one of the reasons. At that time projects were running overtime. The software was very insufficient. The quality of software was very low. The software often did not meet any requirement, right? The average software project overshoots is scheduled by half. So at that time software was never delivered almost. So all these were the causes of software crisis, and these are very kind of uh, too cumbersome. So for preventing software crisis, there are some guidelines. And what are they? The reduction in the software office budgets. The quality of software must be high. Less time needed for software project. Experienced working team members on software project, and software must be delivered. So all these actually helped to overcome all this crisis. So we are done. And there are three important questions into it. The first is the various software characteristics, so and explanation of each and every one of them. What are the different software applications in software engineering? And third is what is software crisis? Describe in detail. Right. So for any problem, please feel free to contact. Thank you.